Wie viele Leute sind im Internet noch?
18.
Hey,
Mehr als hier, oder?
Yeah. Okay, so the core stays. Yeah, I'm super happy you stayed. And
Wir können auf Deutsch switchen, oder?
I think the internet is English still, still mostly English. But you can of course just ask questions in German if you want. So what I'm going to demonstrate now, I think I just make two little demos. And in the end I show you a third short thing that demonstrates how cool and powerful everything is. Ah, we get more visitors. Very good. And what you see here now is our development environment. It's a Visual Studio. And currently it's using vvvv, so the 3D render engine that we want to develop for vvvv, is connected to Visual Studio. And this is also one of the reasons we haven't published it yet, because of course we want to have a workflow that is similar to Skia, that you just start vvvv and create a renderer and you don't have to use Visual Studio. But currently, because of technical reasons, it's like that. And for this project, it wasn't a problem at all, because we are all developers, we know how to use that. And if the system is set up once, you don't have to do anything in Visual Studio. You just have to press the play button, but the setup and building the connection between vvvv and Xenko currently works the best with Visual Studio. But at some point, of course, we know also that it's possible. Will be just directly connected with vvvv, and then also more designers should have it much more easy to use it. So let's look not at Visual Studio anymore, just start it up. And this is not our Xenko development environment. This already is maybe a user project that you created with Xenko. I think I can show the game engine quickly. It looks like this if you install it. Maybe also a little bit of a history that, new version, thanks. Currently updated. Great. They have a nice launcher that you can download, and you can install different versions of the game engine, and then just start it. And it looks like this. Has a very similar user interface to Unity, I think. Maybe let's actually open the solution. That's also the game I will use now for demonstration purposes. Looks like this if you start it up. Everything loaded fine. So this is already something maybe you're used to from a 3D program, or if you used Unity or Unreal before. So you have a very classic setup of the windows. You have a render window inside. Then down here you have assets, models, skeletons, animations, skybox, things like that. And for this game I also already imported some models. For example, our famous V from the vvvv asset folder, vvvv beta asset folder, Teapot and something, and you will see them soon in the patch. This is how it looks. If you're interested, they have a good written documentation online. You can just download it, use it. It can export games for Linux, Mac, Android, iOS. You can just use it like this. There's a nice license, which is MIT. And I think it's a very great piece of software. And it uses the same technology as we use. And that is the big thing for us, that we can now use the game engine and connect it with VL. And that's what we did in this game also. If I now start the game like this, Control F5, starts up. I can now close this, and you saw just the Xenko editor, which you use for design time. So you just prepare assets and your game. And if you connect vvvv to it, you just start the game, it's running, and then when the game runs, you start the development. And that's, of course, our main core workflow that we want to promote, and that's what we want to make. That you have a running software, so this is an empty game, just has a ground floor here, and nothing yet is connected. But you see when you check the document, dependencies, it has a nugget via.xenko reference, and this gives you in the node browser, and you carry with Xenko, and there is already a lot of nodes and things inside. So usually when you use vvv, you would create a renderer here and then get a window. So this is something we still have to solve, and also a reason why it's not published yet. But the nodes and the node set and all the tools are already there, and I'm going to show you some of them now. So we have the normal game window, that is the game. The game is empty, you saw it in the editor, nothing inside. And now how game engines work is they have many of them. I think Unreal uses a different system, but Unity and Xenko, they use a system which is called entity component system. Which is basically a tree of entities, and each entity has components, and depending on the component, the entity behaves differently. For example, you can add a model and a material component, and then you render a model. Or you can just add an audio player component, and then the entity will only play an audio. Or you can come up with logic or physics or whatever components that you add to the entity, and depending on the components, the entity behaves differently. So we'll see that also in a minute. But to get the topmost entity, which is called the root scene, we have a node for that. It's called root scene, and this is this node here. Let me zoom in. This represents the root of the scene graph in the 3D scene. So here this has an input, you can connect other entities, and you can connect whole scenes, like a complete level of a game or something. In order to add something to the scene, you can just connect something here, for example. Let's use an axis and grid entity, and just connect it here, and it should render. So, okay, we can't move the camera yet. For that, we also have a node. This is called orbit camera. This, and this is the normal 3D camera. So we have a nice 3D scene. We can move it, and that's the basic patch that works. Totally natural. If you use vvv, kind of feels natural. Only thing that's missing here, and that's something we still have to develop, is renderer, window management, and other things. Currently you have to do that in the game engine itself. But yeah, usually it's just a basic setup that you have to do once, and you don't change it that often. So for now, for the project we just presented, this works very well, because we just had one renderer for the eyes, and it was very good. And didn't require to do this development yet. We could just test the engine, use it, and have fun with it. So so currently this looks very vvv-like, but the big advantage of a game engine is that the engine part, or the scene graph part, already takes care of a lot of things that are kind of tedious to do in vvv beta currently. for example, light and shadow management. And the way this works in an entity component system is that you add, for example, a light entity or multiple light entities, and they all are kind of global lights. They are part of the world, and they influence everything. You don't have to connect the lights to your box or something in order to render it in a shaded way. So that's a very nice way of working. So of course, we also have a group here that lets us connect multiple things to the root scene. Here you can also press Ctrl+ to have multiple inputs. So let's get back to Axis and Grid. And then let's just put a box here, box entity. And you should see when I connect this, you see a black box. And we don't have any lighting system yet. And in order to do that, we just have to create an entity which is called directional light. And connect this somewhere into the scene graph. The engine recognizes, okay, now there's a light in the scene, and it starts rendering the light. So it looks kind of wrong, but actually it's right. It's just a rotation that doesn't work. This, so let's put here, vector, and now let's rotate the X position a little bit. And you see there's already, the directional light already comes with a shadow that renders on the floor. And you don't have to do anything. You just think very logically, okay, I have a scene, I just put the light there and it works. You don't have to take care of or any shader stuff or something. So you have this high-level engine scene graph thing that Xenko has, which is very nice. It works very well.
Is there already like a glow post effect on it?
There is already post effect and stuff running. There's tone mapping and things running. You can of course disable everything, but for this demo I left it on because it demonstrates how easy it is to have post effects without having a complicated patch here. So yeah, they have some glare already, you see, and some glow. And let's for example, add another, let me put this over here. I think the intensity is a bit high. No, it's fine. No. We can also give the light a color. For example, the light has properties like, you see, orientation things. The red light. But for now, let's keep it white. Just translate or transform the cube a little bit. You see the box has a transformation input. Let's move it a little bit up. So now you can of course start to do animations here and things like that. And what I want to do is I want to put this away into the scene content. So the way you usually structure a patch is the same way here. You can just press, let me already cut this. Then I want to have a new node here. Just make Control P. Call this my scene, for example. Then I paste it here. I already also added group entity here. This, and that's the output. Let's go back. Then we have the thing here. And for vvvv patcher, this kind of feels very natural already, except that you have lighting and things. So let's add another thing, for example, a sphere. here entity. I'll also transform it. Move it maybe to the side. See? So it still looks a little bit sterile or a little bit not so nice. The reason is because those things are just white, and the environment light only has one directional light. So we're going to add another light source, a special light source soon. But let's first check the box and the sphere, how we can change their appearance. So here you have an input which is called material. And that's the same if you use Skier before. Skier has those panes. And this kind of separates the geometry and the physical position in space from the drawing, from the look. And that's a very nice new feature that isn't there in the beta. But here in this engine, you have this idea of materials, and the material actually is the rendering pipeline, how the model is rendered. If you don't connect the material, it gets this plain white thing, but we can connect the PBR material, which means a physically based rendering, and connect this to the box. Now, what's also cool is I can use the same material and also draw the sphere with this material. So this already is an advantage that you have when you separate the drawing from the geometry, that you can use the same render pipeline for both things, for the same appearance. So it still looks the same because it's white and has some basic properties that are the same as the default. But when I now give this thing a color, you see, it's this, and reduce the color a little bit. And then we have properties like metalness, which change the reflectiveness or the glossiness. So you know, the sphere looks very glossy. So they're very nice physical material properties that we also only have in beta if you use Superphysical, for example, which uses kind of the same shading model. But still it looks a little bit, already looks kind of nice, but not super exciting. And the reason is we don't have like a global world light source, but we can add it, and this is in games usually called skybox. And if we put the skybox here, you will see the rendering immediately looks totally different. So now you have this environment light that is different a little bit from depending on where you look. And it gives the materials and the rendering a very nice, like, natural appearance. And then if we go back to the scene, we can like change it to more like a plastic look, super non-glossy, or super glossy but not metallic, or very metallic look. And maybe you have to use a different color that it actually looks like a metal. Maybe more saturation. So it's more like a silver thing. So there are very nice properties that you can use with this with the Xenko rendering engine. So I think that's it for the basic rendering pipelines. As you can see, it's super easy. Do you have any questions or something?
Light probes,
Yeah.
do you have them in?
Xenko has light probes, but we didn't add nodes for it. But Xenko has it, yeah.
Yeah.
You can place them in space and then bake some materials. But We haven't looked at it, so we don't have notes for it.
Concerning the group entity,
This one?
you've got a light connected to the main patch.
Yes.
You have lights connected to this group entity, so you basically can make a couple of these main group entities with different lights, and they only interact with the objects connected to this group.
Yes, totally. You can, for example, yeah, let's do that. That's a good idea. We also, no, we have to separate only the lights. Let's make a group for them. Group entity to use these lights and put it here, so it should look the same. Then we can duplicate this and do, for example, we can have two lights here. Let's add a second directional light, a different color. So maybe a bluish light source. Also a slightly different rotation. And if you now connect this light setup to here, we should see, I think, even two shadows now. We see a little bit here on the sphere, we see that we have two. You see you can, now we have two light sources. Now on the floor. And if we go back to this one, you have a different light setup, which is also a super cool feature that you can switch lights differently, completely change the mood of your rendering.
Is it like also possible to just light one sphere with this light and the cube with another light? And
I think that's
grouping
also
them
possible, yes. Xenko has something they call render groups. So you can assign lights and objects to one render group, and then other lights and other objects to another render group, and only they know each other. But we haven't imported that feature yet. It would be maybe
so putting them in two different groups wouldn't help, because in the end, if you merge them together, there's
no, they're
one word.
part of the same scene graph. Yes. But Xenko has ways to solve that. Yeah.
You said you're still in development. When do you think we can get ahead of it?
Good question. Of course, I think there will be an announcement very soon that announces our plan, and roughly speaking, when people ask that, I think end of the year. So still a few months, roughly. So what was the second part I wanted to show? Yes, also that there is super easy model loading and spreading. So we have the sphere in the box, and let's start. Move that here, add one pin, and let's load a model. And model entity, and this is the same as the sphere in the box, only that it loads a model that you imported from a 3D engine, for example. You can also connect a material to it, so we render it, but you shouldn't see anything. Or it has a default thing here. Because I already have this asset path here, which is one of the geometries we imported, then I think we have to, it's super huge, let's scale it down. So we have the V here. You can see it has some culling issues. I think materials can, so no culling. So let's see. Maybe it's a problem with the lights. Oh, two lights works well. Okay. Let's do it like this. So this is the model you maybe know from vvvv. And spreading works the same as maybe if you were in the sphere workshop. It's the same thing. You can just select something, surround it with, for example, for each loop. Then you get multiple entities out here. Then we also have a group spectral entity, and this goes here. And then have linear spread. Put one, should be back, yes. So uniform scale, and let's translate it. And put this in the X maybe, vector join. Delete. And change the X direction. Now we should see 2 or even V, 4 V's with 5, 10. So in that way, you can very easily import models and build scenes. Yeah, so that's the first demo, which is kind of the easy engine workflow. So think on a high level, everything is easy going, and you can think of lights and environment maps and things like that. And have your scene set up on a different place than your models and your geometry and things like that. Then separation of the materials is interesting. But sometimes, and most of the time in the project we just showed, you want to have direct access to the GPU and do stuff there. And for example, write shaders also. And to demonstrate that, let's make another node. Call this shader scene. And here in Visual Studio, I have a very simple, very easy shader, which is super short. It's only those lines. What it does, it takes a few variables from the system, vertex ID, instance ID, and then just creates a line of it, or some positions. Nothing fancy. Only interesting thing here is that the shader language is also something that was developed by the Xenko developers in Japan. And shader language is very similar to HLSL that we have in vvvv, but it's much more succinct. You don't have to write so much code. For example, you see the stream keyword here, which is a super nice way to pipe data through your shader pipeline. You don't have to write input and output structs here. But the thing here is that this is a very easy shader. In custom drawing, maybe you need to do that in your project. For example, what I told earlier about the particles and the dots. Maybe that's something you do here in the pixel shader. And then you've written this shader, and in order to render this shader, you go here, go into Xenko, and then there's a category called, currently it's called Effect Clip. You click this, you see like hundreds of shaders, and all those shaders are part of Xenko. So Xenko already has a huge library of all these lighting shaders, compute shader, base classes, and things like that. And what you also saw here is you can do shader composition by adding things here. So it's super flexible, but currently we just want to use this draw dots shader, which is also part of the effect clip category I just showed you. And if you create it, you see this node which represents the shader. It's not something that takes a geometry or things. It's just this shader. It's kind of a compiled code for the GPU. And now you can take this code and say, okay, now I want to execute this code or this shader. And to do this, you need a draw call. It's called a draw call. And here we use a null draw because we don't have any geometry. Null draw. And we can connect the shader here. And the null draw has an output which is also part of a kind of a layer and group system. And we can translate this to an entity, and it's called low-level entity. And so this can be connected here. So this is the low-level shader world here, and this node translates from the low-level shader rendering world to this entity engine world that is used to draw the stuff here. Okay. So we have this, so that's also connected here. It doesn't render anything because we didn't put in any data. So what we need is, we need to tell a draw how many vertices it should draw. We need to tell how many instances it should draw. So let's 10, 10, 10. And then it generates some transformations. What's the linear spread, for example? Oh no, I think we don't need that actually. These are just details in quickly. Same things. So I'm just generating some transformations here. And now the interesting thing is I can put them into a dynamic buffer and then upload this buffer to the GPU and provide it to the shader. So we have thing now, let's say 10 transformations. So we have 10 instances and also 10 vertices. And now it should render something. Did I forget something? So we have the shader, we gave it some input data. We have a draw call. And what is missing? Point list should be correct. I have to finish patch. Let's. So that's the thing. Dynamic buffer, draw dots. Oh, well, that's it. Should work.
Liegen die Sachen da drüber im Blender?
maybe, yeah, let's disconnect the scene here. And let's see.
Front back culling.
What? Ah, culling. Let's see. List. I think I was adding the transformations like this. Ah, there they are. Yeah. So just one more. And let's do some more. And some more points. So this is directly using a shader to draw stuff into the scene. And the cool thing is that if you now enable the other scene, edit, that they draw correctly. So they use the same back buffer, the same render pipeline in a sense. So
would this compile on multi-platform systems? In terms of like the shader?
Yes. Yeah, totally. So this is what Xenko can do. They can take this shader, transform it for HLSL to DirectX or to Vulkan or mobile platforms. They're able to use this shader and compile it for different platforms. Yeah, that's a cool thing. So that's also, I think, the end of this demo now. So you can do low-level rendering like this. Direct shader calls directly into the scene and directly manipulate pixels, and you also have a high level engine part of lighting and stuff like that. And we think that's a cool way to do stuff, because sometimes you just want to place a model there, you want to put a house or a tree or something in the scene, but sometimes you have to render 10 million particles or so. So any questions?
Yeah, it's really nice because the workflow looks a little bit like the X11 vvvv beta style. You
Yes.
fill a buffer.
Yeah, do a buffer.
Feed it to the shader.
But there's one more step, and that's the cool thing. And I also have a very short last demo where I don't patch something, I just show something that is already finished. But the separation of this draw call and the shader itself is kind of cool and important, because now you can just use this shader, put it into multiple places, feed it with different data, and then do different draw calls on it or things like that. And buffers and resources can be managed. So buffer is just a memory on the GPU, can be managed with an object-oriented way. And that's the last thing I want to quickly show you. That this separation was also used in the Ocean of Air project, that we defined some sources, some textures, some buffers, and they were shared across multiple shaders. So those buffers can not only be used to read, but shaders can also write into them. And then you can write into such a buffer, and then take the same buffer and connect it to another shader, and then they are kind of have shared memory where they can both render something. And that's the last thing I want to show. So let's disconnect these two scenes. This. And that's GPU particle system demo. Let's me quickly just go on here and show you this. So you see here, this is also just a shader, it runs here. It creates a particle system, and it has some very simple basic behavior now. And if we take a look into the particle system, we see we have one buffer, and the buffer does exactly what I said currently. This buffer contains all the particles. There's a simulation shader that runs the simulation, or it's even a part, it's multiple shaders. Oh, it's one shader, simulation shader. And then there's a draw shader. So the simulation shader is a compute shader. It just works on the memory, modifies the memory, calculates position, behavior. And then this draw shader takes the same buffer that is called after the compute shader and then draws the particles. And that's a very cool thing that you now can share GPU memory between different shaders. And then the even more cool feature is that vvvv now has object-oriented programming, that this you can, and that maybe goes to the question you asked, what is the cool thing with loops and vvvv and state management, is that you now can use this particle system, put it into a loop, and from the outside, without knowing anything what this does inside, you can just create 10 of them, and they all work. Yeah, that's super crazy, I think. They are completely independent, they have their own positions, they have different colors, and they're completely independent. We can add, I think we can add a lot of them. Let's do 35 or so.
Kill it.
Yeah, kill it. Let's try 50. Maybe. It's still, because it's all just shaders and GPU rendering, it works well. And we can do, so each one now has a particle count of 512. Let's do 2488 per system. Damn. And still, I think FPS is super fine. Just render millions of particles here already, I think. No, not millions. It's just 2000 by 50. Yeah, let's go, I don't know, 8. 1, 2, 9. Oh, this is 9, 2. 6, yeah. Still doesn't care. Super fluid.
So from where did you get the color and the behavior from
The behavior.
From sender to
Yeah, the behavior is a very simple, basic thing that just is here. It's the simulation shader. That's a shader, and the shader is written also in this shader language. Let's see. It's a demo from Xenko. I can show it to you there. But it's a short compute shader that makes this behavior moving from the center. And the drawing shader is just take a particle, render it as a quad piece. Yeah, it doesn't look fancy, it's just demonstrate that you can like interactively instance everything, and all the management of the CPU resources or GPU resources gets managed for you, and you can have as much complexity as you want. And in here, outside, you just make a loop and everything works. You just have some input parameters. Target strength, I think that's kind of a funny one. Can we initialize it? Reset, yes, it's reset then. Now we are faster. Yeah, so you can interactively change. Reset all of them. Or reset just one of them, so it can be rushed. It's here, I think. Demos, draw particles. It's a very simple geometry shader. And simulation shader is one compute shader that takes this particle buffer, then does some physics. Nathan did it, who also was the main patcher of the project. And a draw shader takes the same buffer, same data type, and renders them. So yeah, in a few months we'll be there.
This might be a special question, but do you see a way to combine Skia and Xenko? Can you take the?
Yeah, we already did that in the in the project. We rendered a little debug window with Skia, and then you can output Skia as an image and use the image as a texture.
But it's going via the CPU, so it's not like.
Currently it's going through the CPU, but since Skia is also GPU based, it's possible to directly use the texture, but we didn't have time to develop that. But in theory, it's totally possible to render some UI here with Skia, and it's all stays on the GPU and it's super fast. Okay. I think I have a lot of overtime now. When did we start? Almost 2 hours. Sorry for taking that. But I'm really excited about it. Can you stay with us? But now, should we have some drinks or so? Or? Also want to mention Sebastian and Elias, who are not here today, who also develop every day on this stuff. Internet questions maybe. No.
Wir haben immer noch 18 Zuschauer.
Ich glaube, das ist so eine Default-Nummer.
Nee. Die sind echt. Sie schreiben auch, bravo.
Echt? Ja. Ah, danke.